Hello, statistics student. This video is for chapter 8.1, part 3. We are looking at another example of finding confidence interval for population mean using a sample. Except this sample is not, we don't have X bar, it's just data. Okay, I have typed this up in an Excel spreadsheet so I can move it to StatDis. But we can also try to do the same thing with LibreText because these are in comma lists. So to find confidence interval with this data, we don't have to actually find X bar and then do it. So let's look at this. So these are specific absorption rate for cell phone, measure the amount of radio frequency energy absorbed by user's body when using the headsets. The legal SAR level is no more than 1.6 watts per kilogram, and the following SAR data are collected for 30 phones. 30? Do we have that many data? Okay. Yeah, I think it is. So we want to find the 95% confidence interval. Later on, they say that. Okay, so what is sea level? They don't have the sea level here. So sea level is later. Is 0.95, but sigma is given as here 0.356. Okay, find a critical value. So should I use so it should be z, right? We'll talk about what is t later. So z at 0.95 would be what? Sea level equal to 0.95 is the area in between. So I do inverse normal again. So do the inverse normal, but 0.90. Is it 0.95? Yeah, 0.95 in the middle, and I want in between. So we calculate is 1.96. So z equal to 1.96. Of course, you can also find upper, right? You can find the above using half of the tail, which is 5% divided by 2. And then C, use the sample to find 95% confidence interval for mean SAR level for all phones. So these are just samples of 30 phones. We want to find all phones using oh, how come it's different? 0.356. So this is wrong. This is 356. Sigma equal to 0.356. Okay. So I just need sea level and sigma is equal to 356, and I input the data into StatDis. So the answer is you put into StatDis. So where's my SAR level? Here. So I'm going to copy it. Yeah, I have 30 data. Copy. And then I go to StatDis. Go back to beginning. So do Control V. Copy the data here. And then I would do confidence interval, mean one sample, use data because I don't know X bar and everything. I just use data and it's 0.95 by default 0.95. And I tell StatDis where the data is. It's in column 1. My population standard deviation, I'm going to give it 0.356. I evaluate. And just like before, it would give the margin of error, which is 0.12739, and then the population mean could be as low as 0.896 to 0.151. No, 1.151. I run a round to 3 places because the sigma given is 3 places, right? Oh, this one is wrong. Is it? 0.1273. I must have used a wrong sigma. So this should be, I should change it. Maybe I should cut and paste it, screenshot it. Oh, where is it? Here. I should screenshot the output. Copy. Yeah. Okay. So I'll change it in the actual one. So change it to 0.12. 0.739, and then it's as low as 0.896 and 1.151. Okay, 3 places. Write it in the form of inequality. So inequality, then I would write as mu and 0.896 kilowatt, 1.151. Plus and minus notation, it would be x bar plus and minus e, right? So what is x bar? Well, I don't know x bar. So I have to go back to here and look at, do they have x bar? Do they output? They don't output any x bar. So I would actually have to calculate it by, I can find x bar by averaging these two. So x bar should be in the middle of these two number. But I can also do, just do data, explore data, just calculate it. 1 x bar. X bar is the mean, 1.024. So x bar is 1.024. And E is 0.127. So I would say 1.024 plus and minus 0.127. So that's how I do the two notation. Can we conclude that it is below 1.6? So let's look at the 2 number. Or everything below. So we can go from 0.896 to 1.151. But 1.6 is way above, right? So all of this mu are below 1.6. So we say yes. It is outside of the interval and it's higher than every numbers in the interval. Because we know that our mu is one of them. So we say yes. Because 1.6 is higher than all possible value, higher than the whole interval. Which is all possible value of mu. What can be done to reduce margin of error? So our margin of error is 0.896. If you want it to be smaller, what happened? So margin of error is calculated by z, right? Alpha over 2 times sigma over square root n. So if you don't want to change your sea level, you don't want to, well, you cannot change sigma. It's just one number. So all you can do is do change n, right? So in order to make this smaller, you divide more number. So that means increase sample size. If you increase sample size, your error will be lower because you divide a bigger number. The last part of 8.1 is somehow we know that, oh, I don't want this margin of error. If I have a sample, I want to do another sample, but I want to collect more, but how much? So this is, if you have an idea of what your margin of error want to be, you can actually figure out what your sample size is supposed to be. So the way to find this n would be, use algebra to solve for n. So if you square both sides, this would be all, square. The square root would goes away. This is sigma square and z alpha 2 square. And then you can solve for n is actually equal to z alpha over 2 times sigma over e. Okay. If you are to calculate by hand, that's what you do. But you can actually use statistics. Statistics has a calculator called a sample size calculator, sample size determination, and you are estimating mean, right? So just tell them what your sample sea level is, what is your margin of error that you want to, and what is your population standard deviation. It will give you the sample size. Okay. Note when sample size increase, E decrease. Okay. When sample size increase, when E increase, sample size would decrease. They go different direction. First example, in the last example where population standard deviation is 356, what sample size can reduce the margin of error to at most 0.12? Our sample of our sample, our margin of error is 0.127, and I want it to be less than 0.12. So what should I do? So we'll use, we would say, I have the same sea level, assuming that we don't change the sea level. What was the sea level that we were doing? I think it's 0.95, right? So we would say sea level is 0.95. We have E is 0.12, and also sigma is 0.356. So use the statis. So estimate sample size analysis, sample size determination, estimate mu, 0.95, E is 0.12, and population standard deviation is 0.356. And then we don't need to tell what the population size is, we don't know. The sample size is 34. So we said that if you do 34, like just 4 more, you would decrease your margin of error to 0.12. Earlier it was 0.127, okay, so almost 0.13. Here, another example, the population standard deviation of students' age in the community college is 15. If we want to be 95% confidence that the error is within 2, so sigma is 15. Error is within 2 years from the real mean. How many selected students must be surveyed? Again, you do sea level 0.95, or I do 0.95 again. My error is 2, but the standard deviation is 15. Really that big? It turns out that I require my sample size to be 217. Yeah, 217. So that's how you can that's all the question that I have. Oh, one thing that I haven't done is I've demonstrated how to use this to do to find confidence interval when I have data, but I can also use a LibreText calculator. So yeah, I forgot to do that one. So let's look at the let's look at my data. So I have to close this because I want to cut and paste this data. Oops, can I? We don't know. Oh, can I cut and paste them? Copy. Oh, I can copy. So now I'm going to use the here. This is confidence interval calculator with data. So and then you Control V in it. So these are all the data in comma list. It's 0.356, right? 356. Sea level is 0.95, right? 0.95, and then we calculate. Oh, in this one, they actually tells you X bar. The lower limit is 0.896. Is it the same as what we have? Yeah, 0.896, and the upper is 1.15. And they give you X bar 1.023. But in this case, they don't have E. So E, how can you have E if you do not have the, you only have X bar but no E? What happens is you can subtract upper minus lower and divide it by 2. So that would be E. Okay. In case you want to find E, it is upper, maybe I'll put it here, upper minus lower. Okay. Upper minus lower and then divided by 2 because the whole interval is actually 2E. Right. So in case you know this, but you don't know, you don't use that this gives you E, but E is actually equal to upper plus lower divided by 2. Oh no, minus lower. X bar is upper plus lower. It's minus, okay, divided by 2.